Hello guys, welcome back to our series on ESP32 using ESP-IDF. So in today's video, we will see a OTA feature that is called app rollback. So as the name says, it will roll back your application from one partition to other partition. So I hope you have seen my previous videos of how a OTA update is done using HTTPS, how a OTA server is set up. If not, I will share the link in the description. You can watch those videos first before proceeding with these videos. Stay tuned and let's. So this is kind of a flowchart that I've prepared to make you understand that how the application rollback occurs in the OTA. But before explaining this flowchart, let us see the partition table for the OTA. So you will get the partition table folder inside the component, and this is the partition table for OTA. So in this partition table, there are three partitions related to the OTA. One is the OTA data, second is the OTA 0 partition, and third is the OTA 1 partition. So what app rollback is, suppose if your current partition is OTA 0, so the code that is executing is from OTA 0, and you have performed an over-the-air update, and the code is downloaded in this partition. Now, if the new code runs first time after reboot, and if there is a bug in the code, or if in case your device restarts, in that case, what this will do is it will roll back to your previous code, that is OT0 code, and it will run this on every reboot. So this feature is useful when your device are on field and bug occurs. So there will not be any issues with the device. So the previous code will be there, which will be a bug-free code, and that will run smoothly. If you can't roll back to the previous version, and if your code gets stuck, then the only option is you have to send a serviceman to that location of the customer, and you have to physically open the device and do every stuff. If I suppose if I delete this factory partition from here, then if I flash the code using the USB, then by default it will first check for the factory partition. If it is not there, then the code will be flashed into the OT0 partition in that case. So now let us understand this flow chart. To use this app rollback, you have to enable app rollback in the SDK configuration. So now consider an example that currently I am running a code in OTA 0 partition and have done a over-the-air update using HTTPS. So now new code is downloaded to the partition OTA 1. The OTA set boot partition will be called. We have seen the OTA data partition in the partition table, right? What it does is it stores the current partition. So it tells the bootloader that execute the code from this partition. This is your current partition. And the OTA state will be set to ESP OTA new image. Now, what is this OTA state? We know there are two partitions, means two images, two codes in short. So each partition, each image has a state. I will just show you in ESP-IDF how many states are there in the OTA. So if we go here, ESP flash partition.h file, these are the states of any image. An image can be in OTA image new, image pending verify, image valid, image invalid, image aborted, image undefined. So when a new code is downloaded, the state will be OTA image new. So going forward, when we understand you practically using an example, I will show you all these states while running the code. Okay, as the new firmware is downloaded, its state will be ESP OTA image new. Right, once the OTA is done, we reboot the device. Now my app rollback is enabled. So in that case, what the bootloader will do, the bootloader will check OTA state. Now our current OTA state is ESP OTA image new. So if the state is ESP OTA image new, now the bootloader will set the OTA state to ESP OTA image pending verify. So what this state does is you have to verify that the downloaded image is correct. Now how will you verify that? You will be having, suppose I have written a self test. The self test can be, I want that once the OTA is completed, my device should connect to the Wi-Fi again. Wi-Fi credentials that are stored in the NV, it will take that credential, it should connect again. So that is my self test. It's just giving an example. There can be any self test cases that you can write. So this process will happen. But during this process, if the device is powered off means it is kind of reboot. If this is true, it will go to reboot, and again bootloader will check OTA state. Now my OTA state is image pending verify. My image that is downloaded, it is not verified. It has not changed the state to the image is valid. So in that case, what will happen? The bootloader will set the OTA image to invalid or aborted, and the bootloader will select the partition OTA 0. That is, a rollback has occurred here, and OTA 0 partition code will run from there onwards. Then after that, you reboot the device n number of times, only this OTA 0 partition code will run. Now suppose if the reboot doesn't occur during this self-test. So if this falls, then if the self-test is successful, like in our example, we are considering that Wi-Fi connection. If my device is connected to Wi-Fi successfully, a cancel rollback API is called. A cancel rollback API is given that will be called, and OTA one partition will run. So the API is called and the image is a valid image now. After reboot, every time this OTA one partition will run. But if the self-test case is not successful, if it fails, then an API rollback and reboot is called. So it will again go to OTA reboot. So in this case, if it goes here, the state is still pending verify. So it will check OTA status, it is still pending verify, and again it will roll back to OTA 0 partition. Once we do a practical, it will be easy for you to understand what are the scenarios in which the rollback will occur and what are the scenarios in which rollback will not occur. So it is recommended that self-test should be written as short as possible. So now let us jump to the ESP IDE and practically see how this app rollback works and how to enable it. This time also we will be using this hello world as the image file that will be on our server, and the advanced HTTPS OTA example that will go into our ESP32 S3 device. So now first thing, how to enable this app rollback. Now this is the code that we will be flashing into our device. Just go to this SDK config here, bootloader config, and here you will get this enable app rollback support. So I have already enabled it to support the app rollback for your device. And now we will just flash this code inside the ESP32S3 device. Rest of the OTA changes I have already told in the previous videos, and I will also provide the link in description so you can check out. The flash is done. As I have not started the server, so it will show an error here. So to start the server, we need to build this hello world. So inside this as well, we have the SDK config, bootloader config. We are enabling this app rollback support. Rest of the code we have kept as it is for hello world. As we know what hello world will do is it will print for something about 10 seconds and it will restart. We will check this condition first, that when it restarts, it should roll back to the previous OTA partition. That is our advanced HTTPS OTA. Our hello world is built now. We have already copied the folder there. Now we'll just copy this bin file, hello world.bin. Okay, we will replace the file here. Always remember that if you do any modifications in this build folder, if you create new certificate or if you replace a file, please restart this server. So I will start my server. Let us clear this and check again. Okay, OTA is completed. 0. See, it has rolled back to it is again connecting to this. It is again OTA is running. OTA is done. And again this hello world is printed. So we have not called this API, cancel rollback API, and the device has been rebooted. So what is happening here is it is rebooting and the OTA is checking. Its state is image pending verify. We will check this state. State will print this state. So it is going here and the OTA 0 code is running again. Okay, now we will print the states. So for that I have written a function here. What we will do is we will first get the OTA running partition and we will pass this OTA running partition to get state partition. Like I said, we are having two images. Both the images will have their individual states. This state is not for a general state. It is for particular partition state. So we will get the partition information from here, which partition it is. So this will be our hello world partition. To get state, we will pass this partition details in here, and in this OTA state, we will get the image state. So what are the image state? These are the image state, and we should get, in our case, we should get this OTA image pending verify. Let us check. So now as we have to check the state, I have printed the state here, and I will just call the OTA image state function. Before that, I will just comment this restart part so it will not get restarted. We will call this OTA image state. Let us build and update this file in the server. Hello world build is completed. Now we will copy this file, replace it in the server, and start the server again. Okay, OTA is finished. Now hello world code is running. Okay, now it is printing the status here. OTA status equal to 1. If we go in the code and check the status, so this is 1, right? So ESP OTA image pending verify, this is the status here. Now the device is not restarting, right? But what if I power off the device? Let us check this case as well. Our current state is still pending verify. Now if I repower my device, power off, power on, see, it has rolled back to the our OT example code. Now we'll check the positive case, how to cancel the rollback. Suppose my self-test is run successfully and my device is not powered off. In that case, this cancel rollback API is called, and after reboot, this partition should run always. Let us check this case. We will call this API. Okay, that is ESP-OTA mark app valid cancel rollback. And after that, we will again print this OTA image state. Now let us build this and upload to our server. So now OTA is downloading, starting OTA. OTA is finished. Hello world is running now. See, the status is 1 initially before cancel rollback, and after cancel rollback the status is 2. 2 means image is valid. So image is validated now. Now let us restart or repower our device. Now only hello world code should be executing every time on every reboot or power restart. Powered off the device. See, hello world is running now. Now I will reset the device. Still hello world is running, means we have confirmed that the image is valid here in this case. Now we will check this failure state, that is rollback and reboot API. If this API is called, our device will roll back to the previous partition. In our hello world file, we will just replace this cancel rollback with this API, that is app invalid rollback and reboot. It will reboot from here itself. Let us build and upload the file to the server. We need to flash this advanced OTA example code because now there is a valid code, that is hello world. So this is our OTA example code. OTA is downloaded. Hello world is running. After restart in 0 seconds, the device is rebooted. Now again the OTA code is running, right? So we have verified this as well. Now one more point to add here is, suppose in this case your application is rolled back to this OTA 0 partition, but you still want this partition to run in your OTA 0 partition, you have to write a piece of code that will check what is the previous invalid partition, because previous this partition will get invalid here, right? And you can set this as your current partition. Okay, so for that, this is our OTA 0 partition. Here we have to write this code. We have taken a variable ESP partition. Using this API ESP-OTA get last invalid partition. So it will give the details of all the last invalid partition if it exists. Right? If it doesn't exist, then it will return null. And if it is not null, means there is an invalid partition, it will set that as a boot partition and it will restart. We will flash it and we will check if it works. The OTA code is running. Okay, download is completed. So after restart again, hello world is printing. So let us see the log first. So here in log first, it is showing that there is no invalid image. So initially there will not be invalid image until our OTA happens and the state is set to the invalid image by the bootloader. Now the OTA is finished. Hello world code is running here. We are performing a rollback using this API, invalid rollback and reboot. So after rollback, again the OTA code will run. So here the OTA code is running, and in the next iteration, it is showing there is an invalid image. So now, as there is an invalid image, what will happen? It will set the boot partition and the device will restart. So the invalid image, that is the hello world image partition, will be set here. So see, the device is restarted here, and again, hello world is printing. So initially, what used to happen if we roll back, it used to run the OTA code, it used to download the OTA image file, and then it used to reboot after downloading. But here we want to set the invalid image and it is there, so it will automatically set the invalid image, and your device will be restarted. So I have covered everything related to this app rollback. If you find this video helpful, do like and share this video, and don't forget to subscribe our channel. Thank you.